Part 2, you are buying a home that costs $450,000. The bank is giving you an interest rate of 4.75%. The mortgage will run for 30 years, and the bank requires a 20% down payment for this house. Part A, how much is the down payment? Well, here, the down payment is 20%, so we're going to go 0.20 of the price of the house, so in this case, $450,000. So if you do 20% times $450,000, you get $90,000. So the down payment for this house is $90,000. The good thing is, though, the house is $450,000. You had a $90,000 down payment. So that means the rest of the money, this $360,000, that's going to be the amount of money that you're going to be using when you use the mortgage formula. Part B, what will the monthly mortgage payment be, not including the taxes? Well, here's our mortgage formula, and the three values that you need to use the formula are M, the mortgage amount, how much you're borrowing, which in this case we said was this $360,000 number. R is the interest rate as a decimal. So here we have 4.75%. We will move the decimal point 2 places to the left. So here the R is 0.0475. And normally the years of a mortgage for a home, and the question does say, is 30 years. So we're going to take those three values, substitute them into the mortgage formula, and then have our calculator determine the monthly payments. So here we have M, 360,000, times 1 plus R over 12. 1 plus 0.0475 over 12, because you make monthly payments, so that's where the 12 comes from. Raised to the 12 times Y power, that's 12 times 30th power, times another R over 12. So we have to multiply again by 0.0475 over 12. All divided by, again, the 1 plus 0.0475 over 12. Raised to the 12 times Y, 12 times 30th power. Take away 1. And the challenge for these questions is A, knowing the mortgage formula, and then B, entering in all the data correctly onto your calculator. Take a moment, try to enter those values in. You're going to be using the alpha y equals fraction template for the entire formula, because the entire formula is a fraction. Then you're going to be using the fraction template 3 more times, because there's 3 more fractions built into the formula. Here, your monthly payment without the taxes turns out to be $1,877.93. If you notice my calculator, what I do is I take the original price of the house, the $450,000. I subtract the down payment, which is $90,000, which means the amount of money M that we're mortgaging is $360,000. Then I told my calculator to use that previous answer. That's second, and then the negative button, because the mortgage formula has that M out in front. So here you're paying per month, not including taxes, $1,877.93. You need to figure out how much in interest you're going to be paying. And here what we do is we take that monthly payment. We take that $1,877.93. We're making monthly payments, so we're going to multiply it by 12 because you're making 12 payments per year. And the mortgage is for 30 years, so you're going to then multiply that by 30. So you're borrowing $360,000, but you end up paying back over $676,000. Here's the precise number. But that's not the interest. You borrowed $360,000. You're paying the bank back over $676,000. To figure out how much extra you paid, you're now going to take that $676,054.80 and subtract the $360,000. So in this case, you're paying in interest $316,054.80. So to figure out the interest, you take your monthly payment, multiply it by 12 since you make monthly payments, and then by 30 since it's 30 years, and then you subtract the M, how much money you are mortgaging. So this is how much in interest you pay the bank back. Now you're going to factor in the monthly taxes. Here what happens, it tells you this particular house, the taxes are $12,000 per year. So the taxes are $12,000 per year. That's going to be told to you in the problem. While you pay that every month, so you divide that by 12, which means your taxes are $1,000 per month. That tax money gets added on to the monthly payment that you make to the bank, which means each month your payment is going to be that $1,877.93 plus the $1,000 in taxes. So your payment every month is $2,877.93. That's how much your payment is, including taxes, every month. Part 3 deals with exponentials, and number 1, United Nations records indicate that the world population in 1975 was approximately 4 billion, and in 2015 it was approximately 7.28 billion. We need to use the exponential growth model to go about answering some questions. So this is the exponential growth model, sometimes known as the law of uninhibited growth. And there's 4 variables. C represents the initial value, or the initial amount. Y represents the new amount after t time has gone by. And letter K stands for the exponential growth constant. And the first step is always to determine what the K value is in the problem. So here what we're going to do is let's let 4 billion represent the initial amount. So 1975 is going to be the key starting point for this question. So the starting point is 1975. The initial amount will be 4, representing 4 billion. And then the new amount is going to be 7.28. It's going to be in billions, but that's okay. We'll translate our answers into billions later. Since the starting point was 1975, then it says 2015. If I subtract those two values, I get 40. So that means the time will be 40 when the new amount is 7.28. And what we're going to do is we're going to plug into that exponential model. We're going to plug into this y equals c times e to the kt power to figure out what our k value is. So I have y, so that's going to be 7.28. That equals c, the initial amount, which we set as 4, times e raised to the k times t. Well, here our time was 40, so it's going to be 40k power. And this is going to be the equation that we're going to use to solve for k. And we're going to solve this equation graphically. We're going to enter in the left-hand side of the equation into y1, the right-hand side of the equation into y2, and we'll go about finding the point of intersection of those two equations. As far as the y min goes, I'm going to set it as 0. The y max is going to be bigger than the biggest number I see. I see 7.28, so maybe I'll set my y max to be 10. Remember, letter K is always a decimal or a fraction in between -1 and +1. If the growth in the question is decreasing as time goes by, K will be negative. If the value is increasing as time goes by, here our population is going from 4 billion up to 7.28 billion. So here our value is increasing, so our k is going to be positive. So when you go about finding k, I told you in class to set the x-min and the x-max to negative and positive 2. This is the best way to go about solving for k by using the point of intersection technique. And if you do this on your calculator, here the k value turns out to be 0.0150. You always round your exponential growth constant to 4 decimal places. So here the equation that represents the world's population, y equals c times e to the kt power. Y is equal to, well, we chose our starting value to be 4, and that's never going to change. So we have 4 times e raised to the k, which is 0.0150, times t power. So this is going to be the key equation that you need to find in these questions. Once you have that equation, to go about answering questions like parts B and C, you just use this equation and your graphing calculator to get those answers. What I suggest you do is once you set up that equation, type that into your calculator, get rid of the other two equations that you used to solve for k, because now you have it. Type that new equation into y1 and go about answering your questions. Using your model, so this equation is our model, find the population in the year 2019. And since we decided to let 1975 be the starting point to give us this value of 4, all we're going to do is to calculate the year is to subtract those two values. So here it's going to be in our problem, it looks the year 44. So now just go to your table and look at the value that you get in the year 44. And the question says to the nearest person. So I went to 44 in my table, I highlighted my answer. But here is my answer. Now this is in billions, so it's going to be 7,739,169,330, and then this 6 is going to kick the 7 up to 8. So here's the approximate population of the world using that equation in the year 2019. Finally, letter C, when will the world population reach 8 billion? So here gives us a little indication. I can look for 8.0 in my table. But what I could also do is this to figure out when the world population will be 8 billion. What you can simply do is find the point of intersection between our equation that we set up and now y equals 8 for 8 billion. You're going to have to adjust the viewing window, though, to get that point of intersection. Before, the x-min and the x-max went from -2 to +2 to find your k value. Here I went from 0 to 50 for my x-min and my x-max because I saw in the table that it was about 40-something years away, and 40 is in between 0 and 50. The y-max of 10 still works. So in this case here, the year will be about 46.2. This says to the nearest year. So that's going to be in the year 46. And if I take my starting point of 1975 and I add 46 to it, it looks like here it's going to be in the year 2021. So that's when the population should reach about 8 billion. Problem 2 also deals with exponentials, and it says Sheila wants to invest $20,000, and she receives offers from 2 different banks. Bank of America, 2.25% interest compounded monthly for 5 years. Banco Popular, 3% interest compounded continuously for 4 years. Which bank offers Sheila the better deal? Well, Bank of America says the interest is compounded monthly. And when interest is compounded a certain number of times per year, we're going to use what I called interest formula number 1. A equals P parentheses 1 plus R over N raised to the N times T power. P is the principal, so that's the money invested, which in this case they tell you is $20,000. The interest rate R is 2.25%. That's the same as 2.25%. And then if we convert from a percent to a decimal, we move the decimal point 2 places to the left. So in this case, our R is going to be 0.0225. T is the time in years, and it says for Bank of America, it's 5 years. And then our N stands for the number of compoundings per year. In this case, the question says monthly, so if something happens monthly, it's 12 times a year. So what we're going to do is we're going to substitute into that formula. So I have A, the balance, that equals the principal, which is 20,000, parentheses 1 plus R over N, 1 plus 0.0225 over 12, raised to the N times T, which in this case is going to be the 12 times 5 power. And we're going to enter that expression directly into our calculator and round to 2 decimal places for money. So our balance, $22,379, and 7 kicks the 8 up to 9 cents. So that's the balance if Sheila decides to go with Bank of America. Banco Popular mentions that the interest is compounded continuously. For continuous compounding of interest, we're going to use interest formula number 2. A equals P times E raised to the RT power. Once again, the principal is that 20,000. E is that exponential constant of that 2.7 number. The interest rate R for Banco Popular is 3%. So if I convert that to a decimal, that's going to be 0.03. And it said for Banco Popular, it's going to be 4 years. So we're going to enter now this expression into our calculator. 20,000 times E raised to the 0.03 times 4 power. So here the balance is going to be $23,470, and looks like the 7 kicks that up to 22 cents. So each bank we have the balance, and the bank with the better deal, meaning more money, appears to be Banco Popular. How much less money would Sheila have earned if she went with the bank that offered the lesser deal? Basically, they're just asking you for the difference of the two balances. So it looks like here, the difference is $1,091.13. Finally, using the bank with the better deal, that's this Banco Popular deal, how long to the nearest tenth of a year will it take for the investment to reach $40,000? Well, Banco Popular uses the continuous compounding of interest. I'm going to rewrite A equals P times E to the RT power. Here they're telling you they want the balance to be 40,000. So I'm going to substitute in 40,000 for letter A. The principal is still that $20,000. We have E. The interest rate R for Banco Popular is still 0.03. But now the question is asking, how long will it take? So here they're asking you to solve for time. So I'll call that X. So this is the equation that we're going to use to solve for how long it's going to take for that $20,000 to increase to $40,000. We're going to solve this graphically. We'll enter our left-hand side into Y1, the right-hand side into Y2, and we'll go about calculating the point of intersection. We need to choose and set up a viewing window, and we're solving for X, and X stands for time. So I'm going to say my X min is going to be 0. As far as X max goes, the maximum amount of time, I have no idea. Maybe I'll look 50 years into the future, maybe 100 years into the future. Maybe I'll start off with an X max of 50. As far as a Y min and a Y max go, a Y min of 0, because Y stands for money. And here the biggest number I see is 40,000, so maybe I'll go up to 50,000 for my Y max. So I'm going to set up this viewing window and try to find the point of intersection for the left and the right-hand side of the equation. So here it looks like, to the nearest tenth of a year, looks like it's going to take 17.3 years for this investment to increase to $40,000.